For each one of these, I encourage you to pause the video and write out your equation, do your best to solve it, and then watch the video in order to check your work. So first try it on your own, then use the video to check. So the first story problem, how long will it take for a $1,000 investment to double if interest is compounded continuously at 5.5%? The first thing that we have to point out is the word continuously. Hopefully that makes us immediately think of a formula, and the formula we're going to think of is PERT. A equals P e to the power of RT. If that's your framework that you're working with, now we just have to figure out what goes where. So hopefully it's clear that P is going to be $1,000. E is E, so it's not a variable, it's a number. The rate, so if we're going to have 5.5%, now let's think, we have to slide the decimal place 2 places, so you have 0.055. It says how long. That means we don't know what T is, and it says that our investment's going to double. So that should take $1,000 and make it $2,000. There's the setup. Right away, what pops into my mind is that we're going to use the natural log, and that's true. But remember, the only thing that can be logged is an exponential function. So this part here can be logged, the rest cannot. So what you have to do is find a way to get rid of that 1,000 on front. So we'll divide by 1,000, divide by 1,000, divide by 1,000, and you get 2 equals e to the 0.055t. Now we can use the natural log. So the natural log on the left side is natural log 2. This is where the nice things happen. Natural log e, gone. So we have this natural log 2 equals 0.055t. And now we just have a division problem. So I'm going to go on my calculator. On my calculator, I'm going to go on here and go natural log 2. Make sure you close it up. And then divide by 0.055. And you've got your answer. It should take 12.6 years for this thing to double. All right, once again, pause the video, see if you can figure out the next one, and then use the video to check your work. So how long will it take for $500 to become $750 invested at 6% compounded monthly? Well, now the framework that we're going to use is A equals P, 1 plus R over N to the NT. And once again, just fill out as much as we can. So we're going to start out with $500. We're going to go 1 plus our rate, which is 0.06. It says compounded monthly. That's 12, power 12. And once again, how long means we don't know what T is, but we do know that we're going to end up with 750. Okay, now let's just use regular algebra and see what numbers we can get rid of. So I'm going to divide by 500 to get rid of it, and divide by 500. When I do that, I'll go 750 divided by 500 and get 1.5. So 1.5 is going to be equal to 1 plus 0.06 divided by 12 power 12 to the t. Now this is kind of an ugly formula, but you can see this is an exponential. Anytime you have the exponent up top, that's an exponential. We're going to use logs in order to solve it. So you can use whatever log you want. I'm going to use the common log just because it's right on my calculator. So I'm going to log both sides, log here and log here. When you do that, you can say to your exponent, you're going to go down in front. So I have log 1.5 is going to be equal to 12t log 1 plus 0.06 divided by 12. Okay. So I have that written out, and it's a lengthy equation, but this right here is a number on your calculator. This is a number on your calculator. That's a number. So all we have to do at this point is just division. So let's try it, see if we can keep it straight. So on my calculator, I'm going to go log 1.5, and I'm going to divide by log everything that's in the fraction, log 1 plus 0.06 divided by 12. Make sure I have that right before I keep going. Okay, got it, good. Good, and then I'm going to divide by 12 as well, because I have to divide by that 12, and we should have it. Looks like it's going to take about 6.7 years. 6.77, 6.8 years. All right, last problem. Let's say you want to be a millionaire when you retire and you decide to save $200 per month, invest it in an account that gives 6%. At what age can you retire? All right, I like this problem because this is really the point of the logarithm. This is a lot of times you say, hey, when am I going to use this in life? This is when you're going to use this in life. If you want to figure out what age you can retire and if your current investing amounts are going to be good enough to retire at age 65 or whatever age you want to retire, this is what the log is for. So, all right, so notice that you have $200 per month, and that to me suggests we're going to invest $200 over and over and over and over again, which we have been calling an annuity. When you use an annuity, you have a different formula. The formula, so we don't forget, your final amount of your annuity is going to be your monthly payment. And here you're going to have your 1 plus R over N to the NT minus 1 divided by R over N. So that's going to be the framework that we work with. So let's give it a try. We're going to go $200, and then in parentheses we have 1 plus my rate would be 6%, 0.06. We're doing this per month, so divided by 12, power 12. And then it looks like we don't know how long this is going to take, so we're going to put a X or a T right there. Then we'll go minus 1 all over 0.06 divided by 12. A great question is, what are we going to set this equal to? And it says we want to be a millionaire, so we're going to set this all equal to 1 million. Of course, it'd be nice to have more than that, but if we can set it equal to 1 million, that'd be great. All right, here's the problem we have to solve. It looks like a mess, but if you can keep things straight, it's really not so bad. The first thing I'm going to do is divide by 200 on both sides. So 1 million divided by 200 is going to be 5,000. So I have 5,000 is going to be equal to this entire fraction, 1 plus 0.06 divided by 12 power 12 x minus 1 over 0.06. Okay, once again, still pretty ugly, but I can say it's divided by this number. So to get rid of division, you're going to use multiplication. So I'm going to take 5,000 and I'm going to multiply by what's on the denominator here. So I'll go 5,000 and I'm going to go times 0.06 divided by 12 and get 25. So now I have over here 25 is going to be equal to 1 plus 0.06 divided by 12 power 12 x minus 1. Well, hopefully it's clear. The next step, we're going to add 1 to both sides and make it 26. Get rid of that. Now this is the point where I can do a log. I'm going to log both sides. So I have log 26 is going to be equal to 12x log 1 plus 0.06 divided by 12. And now I can, oops, sorry, let me show that to you. And now we can use some division. So I'll go log 26, divide by 12, and divide by log of that number, and we should have it. So we're going to go log 26, divide by 12, and we're also going to divide by the log of 1 plus 0.06 divided by 12, and you should have it. Should take about 54 years. So add that to your current age, and you'll have the age you retire.